Hello, I'm Marc Hornbeek, and welcome to my session, Continuous Quality Engineering, the key to advancing DevOps, DevSecOps, and SRE, which is something I certainly believe. I'm Marc Hornbeek. I'm known as DevOps the Gray. I am CEO and principal consultant of a little boutique consulting firm called engineeringdevops.com, and I'm an author of a book called Engineering DevOps, which is kind of a prescriptive approach to accomplishing higher performance levels of DevOps, and certainly continuous quality engineering is part of that prescription for sure. So I say I'm Marc Hornbeek. I'm pretty well known for helping large firms, enterprises, institutions, manufacturers, service providers with their strategic, transformation efforts. I also help with training and instructing and writing courses. I also help different folks with marketing and sales content. So that's what I do. If you want to know more about me and my firm, engineeringdevops.com is the website. So without further ado, let's get into the content here. What is continuous quality engineering is the first thing we'll talk about. Why is it important to, DevOps, DevSecOps, and SRE? I'll help you try to understand a capability maturity levels and how I assess, CQE, as well as help others do self-assessments for CQE. We'll talk about the pillars of practice for CQE, an implementation roadmap, how you can organize your own roadmap to implement higher performance quality engineering, and some, near-term strategic considerations. So first of all, what is continuous quality engineering? First of all, it's certainly more than just testing. People talk a lot about continuous testing, and certainly, continuous quality engineering encompasses and includes continuous testing, but continuous quality engineering is more inclusive in the sense that it includes design, development, implementation, sustaining of systems and practices, continuously assessing and improving quality of development, delivery, and production and those processes. The roots of CQE go all the way back to, Dr. Edward Deming, where he was the, well-recognized American quality statistician, that he defined quality as a dynamic thing. It's necessary to adjust quality systems and practices continuously was one of his mantras, and he was kind of the inventor of the, act, plan, do, and study cycle. So a continuously improve cycle, and that's proven to be extremely valuable for many firms across the world. Dr. Deming, certainly one of my heroes, and I attribute a lot of his teachings to the underpinnings of not only continuous quality engineering, but ultimately, DevOps, DevSecOps, and a lot of the practices in SRE as well. All right, so what's the scope of continuous quality engineering? We're not talking about just some sector of a value stream. Continuous quality engineering includes quality practices for the whole end-to-end value stream, all the way from, requirement definition through to production operations. So certainly it's much more than just continuous testing, because a lot of things happen in there that are more than just test execution anyway. So it includes activities in planning, development, the CI/CD processes, deployment, and in production operations and security operations. It encompasses the quality aspects of Agile, DevOps, DevSecOps, and SRE. Okay, certainly it's important. It's important certainly to DevOps, DevSecOps, and SRE. If you think about what's happening in DevOps and DevSecOps, you're really trying to accelerate continuous delivery and deployment safely and securely. There's an awful lot of testing involved pretty much every step of the way while you're doing that. On the SRE side, you're really looking at assuring reliability, quality, scalability of services in production, at scale. And again, there's an awful lot of testing involved in that. What's in common is the testing, cycle, creating tasks, assigning tasks, provisioning test environments, running tasks, reporting test results, determining the verdicts, and a lot of analysis. So that cycle appears many, many times across, these value streams. And if you break it down kind of by the people, process, and technology dimensions, there's a lot of practices associated with, continuous quality engineering. So on the people side, certainly promoting collaboration, monitoring for quality amongst teams is a good way to help communicate with each other, is have good metrics that everybody can share across the different teams. Process of making orchestration of test environments and automation of the test tasks and quality engineering tasks working at an appropriate level of quality coverage, which is certainly important to understand. And finally, the technology, so the various platforms, tool chains architected to enable sharing of quality artifacts and again, across the entire end-to-end value stream. And many of these modern services and systems, it's more than just one value stream. It can be a whole federated set of value streams that make up an actual service. If you don't do this, of course, there's lots of consequences, and these are just some examples of failure cases. If you're not including, quality requirements at the planning stage, and if they're left out of the plan, often you're going to end up with delays and cost overruns, production problems, because you hadn't factored that into your plan. Within development, not creating automated test cases together with the software changes can result in longer CI/CD lead times, because you're going to have to do that during CI/CD instead, which would slow down the CI/CD. Within CI/CD, if you got too many manual tests, that's going to be, slowing down the processes during the deployment phase to production. You'd have to manually, validate production deployment decisions, and that can be an example of, another delay. And finally, in operations, it could be slow to verify restores and recovery of production issues. So these are just some example failure cases. There are many others, but just to underscore the idea that, continuous quality engineering is applicable right across the value stream. And if you don't consider it properly, there can be lots of consequences. Here are some published reports, recent ones, that are relevant. The state of quality engineering, there's a state of quality report 2023 that was published. And, the good thing is that 79% of the folks that responded saw a positive return on investment, even within the first year of adopting test automation and some of the continuous quality engineering practices. Some of the most effective techniques were automating integration and system testing, automating unit testing, getting involved in more automated and complete code reviews and inspections. The list goes on, but there are many areas where continuous quality engineering can apply. Not to say it's easy. There's plenty of challenges. Getting the requirements right is often, from products that are being tested, is often one of the big challenges. How do you apply testing if you don't know what the requirement is? Getting teams skilled up is another one that definitely can impact your ability to transform to CQE practices. Difficult to integrate different tools. Certainly, if you don't have a platform that is easy to integrate tools, that can be a big bottleneck. And finally, last on the list, but not last in terms of total issues, but codifying, costly test maintenance. So if you don't have a good strategy for maintaining quality practices, then that can bog you down as well and slow down the transformation. There are lots of things involved in continuous quality engineering. These are according to the World Quality Report 2023. They identified 7 pillars, and I would add a couple of more too, of areas of practice that need to be mastered to really have very high performance quality engineering. So orchestration of quality activities, things like setting up test environments and getting things ready for testing, automation of the quality activities once the environments are set up, involving quality, the infrastructure to support quality and data provisioning, defining, tracking, and monitoring quality indicators, upskilling, for quality practices, platforms, and tools. There's a lot of skills required there that teams need to get familiar with and master. Embracing things like smart quality technologies, especially these days with AI becoming more and more relevant and useful for various quality initiatives, and value stream management platforms we'll talk about. So there are 7 pillars, and on top of that, I would say there's a lot of important things that need to happen amongst leadership and also the culture as well. So I would kind of break that down as 9 pillars. I guess I'm a little famous for 9 pillars of DevOps and SRE. So this is an example of 9 pillars for SQE, or CQE, I should say. Okay. If you think about maturity levels, you can come up with your own maturity model if you want. There's certainly no standard one, but this is one I like to use when I think about continuous quality engineering. At the lowest level, it's really unmeasured, a little bit chaotic. There's no automated pipeline in place. QE metrics are not really reported much. Lead times are not even measured, let alone valued much. The next level of maturity or capability you'd have an initial pipeline, so an initial CI/CD pipeline in place. Some of the QE tasks and metrics are automated and reported. By this time, you're going to start at least getting measurements for your lead times to, for changes into production. Level 2, you've now got a more automated pipeline. Quality engineering tasks and metrics are pretty automated. QE metrics are, reported for the pipeline, and release management decisions at least use the metrics. Lead time in this case is typically going to be something like a week, or at least measured in weeks, not longer than that. Level 3 is a more advanced continuous delivery process where QE tasks and metrics are fully automated sufficiently to automatically approve a release. So the culture uses metrics to steer the continuous improvements. In this case, you could actually get to lead times, measured in days or under a day. Finally, level 4, the elite level, is where you have continuous deployment happening without any, human intervention. You could actually do a deployment. So quality engineering tasks and metrics are fully automated sufficiently to approve a release to be automatically deployed to production. And that means you have to automate all your release policies and so on, including quality engineering metrics. The culture routinely uses metrics to steer continuous improvements. And in this case, lead times can be even less than an hour potentially, or certainly measured in hours. So you can see the progression here. You might want to know where you are on your, in your quality maturity level. The last chart gave you some ideas. If you want to get a little more refined about it, I have a tool on my website, engineeringdevops.com. You're welcome to download it and use it for free. There's a lot of information there that you can download and use for free. So if you think about the 4 levels I talked about and the 3 dimensions of, people aspects, process, and technology, you can kind of go through the list and say what's the best fit for your environment. In this example, I'm showing the pipeline or the application, fit best level 1 for people and level 2 for process and level 3 for technology. So it gets an overall score of 2.3. So very, very simple, almost at a glance type of self-assessment, not a detailed assessment. There are more detailed self-assessment tools available on my website as well that go into a lot more detail in terms of specific practices that you could assess. If you think about a roadmap, the first thing when people say roadmap, you're kind of going from somewhere to somewhere else. So in this case, you're trying to go from some level of maturity to some other level of capability or maturity, however you want to call that. Let's say from level 0 to level 1. If you're at level 0 mostly trying to get to level 1, here are some of the things you could do. And again, there's no standard here. These are just some concepts and that you could embrace to try to get to the next level. For example, select a platform, initial tools for quality engineering, orchestration, and automation. That would be one of the first things I would do. Make sure you've got a platform that you're going to live with for a while. For automation and plugging in other tools. Determine initial infrastructure and data provisioning requirements. So basically an inventory of what you need to do testing. Implement an initial pipeline. That's easier said than done, I know, but that's certainly part of this initial, to get to level 1, at least have an initial one. Maybe it's not fully automated, but you at least have all the steps in the pipeline identified and in place. Define and implement initial metrics and monitoring, including things like lead time, which is usually the most important metric for most value streams and pipelines, but it's not necessarily the only one, that's for sure. Train the team on using the platform, the tools, and the metrics. Include quality engineering requirements in planning and backlog. And make sure you've got some cross-functional communications going on with QE, knowledge sharing. Maybe you have a, COE or Center of Practice or Center of Excellence to help do that, and at least some ad hoc quality engineering training. And if you do all that, I think you honestly get, to level 1. You could qualify for a level 1. You can set up your own scoring mechanism, by the way. This is the way I like to do it. To go from level 1 to 2 is harder, of course, but now you're going to have a complete CI/CD tool chain, including quality engineering and security scanners and test tools. You're going to have to automate the infrastructure itself and data provisioning, implement sufficient QE and security metrics needed to actually automate release decisions. Leadership should be, at the level where they're sponsoring CQE efforts and collaboration between the cross-functional teams, the DevOps folks, DevOps people, security, QA, SRE. and a training program should be in place. So these are examples of things that I believe should be in place before you could consider yourself a level 2 CQE. Once you get to 2, you want to get to 3. So again, there's additional things you can do. Now we're talking end-to-end CI/CD pipelines should be fully automated to the point where at least delivery, if not deployment, is sufficiently automated so that a number of quality and security scans and tests are fully automated. Results are used to automatically determine if a release meets QE, security, and SRE requirements for deployment. And the culture exists for collaboration, learning from failures, shared DevOps, security and SRE metrics are shared together, and focusing on removing bottlenecks, putting in place SLOs and SLIs, getting DevOps mentors together to help, and guilds to help share the knowledge across the team. Here you're looking at lead times maybe in the less than a day, so it's fairly advanced level, even 3. Level 4, which is the ultimate level. To get to level 4, you really need to have a fully automated, end-to-end value stream with even the deployment decision and the actual deployments being automated. So most quality and security scans and tests are fully automated. QE results are used to automatically deploy and take an approved release and then deploy it. The culture of continuous experimentation and learning from failure should exist. This is along the lines of, the third way of DevOps, continuous experimentation and learning. So that should be going on proactively. And here you could probably achieve lead times that are measured in like hours rather than days. Okay, so those are some ideas for a roadmap. Again, they're not standard. You could create your own, but it gives you some ideas how to do it if you're not familiar with it. Let's think about the future a little bit. Certainly a lot of talk about AI these days, using smart technologies, and they certainly can apply to continuous quality engineering as well. There's a cool section in this State of Quality, Software Quality 2023 report that I found handy. It says that AI can help with test case and scripts generation. 51% of the folks that responded said that that's pretty much a real thing these days and can be done. So at least half of the respondents are looking at doing that. Applying AI to test generation, a little less, but certainly a significant number. Defect and bug detection. And you can see, practically every aspect of test automation and quality assurance expects to get some benefit from AI, if not now, but in the near future. A lot of potential, and I'm certainly seeing that in my own consulting work as well. More and more clients are looking at tools that are driven, at least in part, by AI and machine learning. So that's exciting. The other technology that I think hasn't been leveraged as much as it could be, and the same report calls it out too, quality can be integrated with value stream management platforms. So you've got a management platform. Here's an example from Plutora, but a lot of them look much the same. You've got plugins that can then integrate in a common data structure and apply management decisions and get analysis of what's going on across the entire value stream, and not only one, but even a full set of value streams. So you can have multiple pipelines within multiple value streams being supported, and gets particularly interesting when you have complex services with lots of value streams or microservices and things like that. The modern applications that have multiple parts that are having to be coordinated or at least managed one way or the other. So a value stream management platform can provide enterprise scale QA integration, orchestration, test automation, and analysis over the multiple value streams. By that, you can end up with a more unified view of the data model, APIs, maintenance practices, how you're doing orchestration and automation, resource management, analysis, and dashboards. It's basically a layer over and above, the pipeline and the value stream, which makes a lot of sense from system engineering. You want to separate, the controller from the controlled, if you like, and the value stream management platform helps you do that. Okay, so we're getting near the summary of my talk, but fundamentally, continuous quality engineering does realize almost an instant ROI. And these days, instant means, in the first year of operation, you got a significant project. And certainly a lot of these transformation projects are quite significant, but you get very quick return on investment. I have not seen too many quality engineering in test automation projects that don't have very fast ROI, except ones that were, really a failure. Most of these projects do very well. So in summary, continuous quality engineering, which includes the concepts of continuous testing, is a foundation for DevOps, DevSecOps, and SRE success. Continuous quality engineering projects realize, very fast ROI, so-called, not necessarily instant in terms of, zero time, but very quick. Usually within the first year, you get, more than your money back for what you invested. The second point here is the capability maturity levels, self-assessment tools, and even roadmaps can help you build your CQE implementation to improve your capabilities. And you're welcome, as I say, to go onto my website and download at your leisure different tools, or you can call me and I'd gladly help you. CQE strategies should consider some of the newer techniques, so AI tools, value stream management platforms to further improve quality, speed, scale of continuous deliveries and production operations. So that's basically my talk. I hope that you found it informative. I know that you're busy with other things, but I want to emphasize that quality engineering is a key part of all of the things we're discussing here at this conference. You want to have an ongoing conversation with me, connect with me on LinkedIn, or send me an email at mhornbeek@engineeringdevops.com, or get onto my website, engineeringdevops.com, and or book an online consult with me here. All of the above is fine with me. I enjoy helping people with these types of things, and hope you have had, I think I'm one of the last talks of the day, great conference. And if you have any questions for me, please email me. I'm not currently sitting in your time zone. Unfortunately, I wasn't able to join in person this year, but I hope to in the future, and I sure hope you had a great conference. Thank you.